Hello my dear students, this is Akash SD and welcome to the SD Physics classes. Hope so you all are doing really great. So students, in this video we are going to learn the applications of the dimensional analysis 1. That means here in this video we are going to learn the two applications. Okay. Now students, let's see what is the dimensional formula and what is the dimension, then only we can understand the further applications and all that. Okay. So let's see here, first one, the dimensional formula. Okay. So see here, dimensional formula of any physical quantity is that expression which represents which of the base quantities are included in that quantity. Here base quantities means fundamental quantities, and how many fundamental quantities are there? 7. Okay. So if we talk about here some example, and I am writing here the dimensional formula of the force. So dimensional formula of the force, what is there? We can write m power 1, L power 1, T power minus 2, like a mass into acceleration. Mass means m, acceleration means Lt minus 2 from the Newton's second law of motion, F equal to ma. Okay. After the students, if we talk about here, let's take for example dimensional formula of the density. Dimensional formula of the density. So what's the dimensional formula of the density? You know the density means mass by volume. Mass means capital M, volume means L cube. Okay, meter cube. So we can write here m L power minus 3. Even we can write here T power 0 also. Okay. Now students, after that if we see here the dimensions. So see, dimension. Dimension of a physical quantity is the exponent to which the base quantities are raised to express that quantity. Again, I am highlighting the word here, exponent, exponent to which base quantities are raised here. Okay. So if we talk about here the example, let's take here force. So in force, what are the fundamental or base quantities are involved? Mass, length and time. So we can tell here dimensions, dimensions of force are 1 in mass because m power 1. Similarly, we can tell 1 in length, and in time how much? Minus 2, and minus 2 in time. Okay, we'll write here minus 2 in time. Okay, minus 2 in time. So students, here see here dimensions of force is 1 in mass, 1 in length, and minus 2 in water, and minus 2 in time. Okay. Similarly students, if we see for the density, what we can tell? Dimensions of density are, what we can tell? 1 in mass, minus 3 in length, and 0 in time. Is it? I hope so you have understood this very well. Na? Kindly see here very well. We have seen here what is the dimensional formula, and we have learned what is the dimension. Okay. Now students, we are ready to learn the applications. Okay. So see here the application 1. What is the application 1? See, to convert a physical quantity from one system of units to other system of units. As of now, system of units you have seen like a FPS system, CGS system, MKS system. Like 3 we know, but like that so many is possible. Like if we talk about here MKS system. In MKS system, you know what we take? We take mass, unit of mass 1 kg, unit of length 1 meter, unit of time 1 second. Similarly, if we talk about the CGS system, here we take unit of mass 1 gram, unit of length 1 centimeter, and unit of time 1 second. Okay. So like that so many system of units are possible. So see here, this is based on the fact that the product of numerical value n and unit u remains to be same whatever system of unit is used for measurement. What is same? The product of numerical value and the unit is same. Okay. After that, if we see here, see, let n1 and u1 be the numerical value and unit in one system, while let n2 and u2 be the numerical value and unit in another system. So what will happen that here students? What will happen that here? It will happen that here this product n into u will be constant. What will be constant students? This n into u will be constant product. So we can tell here n inversely proportional to u. N inversely proportional to u. And even we can write one more thing to solve the numericals, like n1 u1 is equal to how much? N to u2. N1 u1 is equal to how much? N to u2. Okay. Even if I give one more easy example, like you know here, no? Let's take, if I write very easy, see 1 kilometer equal to how much? 1000 meter. Okay, so if I talk about here, let's take here, this is N1, kilometer is U1, 1000 is N2, and meter is U2. Okay, so if you will see here, you can see very well which one is more, N1 or N2. So you can see here the students, this N2 is greater than N1. So as N2 is greater than N1, what will happen that here? Here it will be, what will be there? This U2 will become less than U1. And you know very well, the meter unit is the lesser than the kilometer unit. Okay, so what will happen that when the numerical value will increase, the unit have to decrease. I hope so this is very clear. Okay, great. Now students, after that, this one we are going to learn that, see, convert 2 kilogram per meter into gram per centimeter cube. So here remember that one thing, whenever the conversion is coming from MKS system to the CGS system, or it is coming from CGS to MKS system. So here what will happen that here, no need to use N1 U1 equal to N2 U2, it will become very lengthy, directly we'll do here. So what we can tell here, see, if we talk about here, see, I am writing it 2 kilogram per meter cube, direct conversion here. So to 1 kg, how many gram we can tell here? Students, we can tell here, see, 10 to the power 3 gram. Okay, and meter cube, how many centimeter cube? We can write here 10 to the power 6 centimeter cube. Is it? Because meter cube 10 to the power 6 centimeter cube. Okay, now all the numerical values will collect together, like this 2, this 10 to the power 3, and this 10 power 6. So it will become what? It will become here 2 into 10 to the power minus 3 gram per centimeter cube. Is it? So you can see very well here, directly we have converted, because MKS to CGS we are going, so directly also we can do, that's not a problem. Okay, after that, students, see, this is the all standard things are there, we are doing, no? All the standard things. So see here, next one, convert 1 Newton into dyne. Okay, so here first you should know very well, no, dimensional formula of the force, already I have taught you, MLT minus 2. So 1 Newton means 1 kilogram meter per second square. Okay, and this is the MKS, and if we talk about here the dyne, so 1 dyne means what? 1 dyne means 1 gram centimeter per second square. Okay, this thing is there. So now students, if I will convert here, okay, so see, next one conversion, so see, conversion, 1 Newton, what we know, 1 kilogram meter per second square. So what we can write here, see, we can write here 10 to the power 3 gram, meter means how much here, 10 to the power 2 centimeter, and here by second square. Now students, what we'll do here, this 10 to the power 3 and 10 to the power 2, we will take together, is it? So it will become here 10 to the power 5, and here units all together, so it will become here gram centimeter per second square. And what is this? This is the dyne. So we can tell students, this 1 Newton is equal to 10 to the power 5, and this will become what? It will become dyne. That means see, 1 Newton equal to 10 to the power 5 dyne. Students, here also N1 U1 equal to N2 U2 is involved, everything is there. Okay, but here we are doing directly because MKS to CGS is there. Okay, all these standards are there. Okay, next one, 1 joule into erg. Here also MKS to CGS. Joule is the MKS unit of the energy and erg is the CGS unit of energy. Is it? So see here students, if I write here, let's take for example 1 joule. So 1 joule means 1 kilogram meter per second square, because dimensional formula of the energy is ml square T power minus 2. Remember that. Okay. Now after that, if we talk about here this erg, erg, this used to be 1 gram centimeter square per second square. Okay. Now after that, if we do the conversion here, now let's take given 1 joule. So what is given here? See, this one is the 1 kilogram. So again I will write here 10 to the power 3 gram. Meter square means 1 meter square. How many centimeter square? So see, 10 to the power 4 centimeter square, and as of now second square. So again what we'll do here students, this numerical value will collect together. So what this will become here, 10 to the power 7 gram centimeter square per second square. And what is this? This is the erg. Okay, so we can write here 1 joule is equal to 10 to the power 7 erg. Even this thing and all you have to remember also. Here what we are doing, here we are converting MKS to CGS, and here what is valid? N1 U1 equal to N2 U2 is the valid, but directly we are doing conversion, no? Because as I have told you, MKS to CGS is there. Okay, but now here you can see, if we talk about here this question, no? This question is little bit different. So see, find the value of 100 joule in a system, okay, which has 20 centimeter, 250 gram, and half minute as fundamental units of length, mass and time. So here what is there? 100 joule means MKS system, but the new system is neither CGS nor FPS. Some new system is there. So there this N1 U1 equal to N2 U2 basics we need. Okay. So how we will approach the question? So first thing what we'll do here, see, the first thing we'll write here, see, 100 joule. 100 joule is equal to how much? We'll write here 100 joule is equal to, see, X units, because we don't know in new system what is the unit. So we'll write here how much? X units. So now the question is transformed to calculate the value of X. Okay. So students, after that what we'll do here? This thing we will compare with N1 U1 is equal to N2 U2. Okay. We'll do the comparison. What we'll do here? We will do here comparison. Okay. So after that, when we will do the comparison here, what will happen that here? See here. Here I will make the two parts because one system of unit and the system of unit. So see here. If I write here what is the value of N1? So value of N1 is how much here? 100. Okay. And if I write here the value of U1. Okay. So for U1 means I will not write here the joule. Here I will write here the dimensional formula, like see M L square T power minus 2. Okay. And here one side of the system of units, so M1, L1, T1, like this. Okay. Similarly, students, if we write this side here, so here N2 will be how much is there? This N2 will be how much? X. Okay. And after that, if I talk about here U2, so U2 also, see, the dimensional formula in any system of unit is same, ML square T power minus 2. But this is the another system of units, so I will write here M2, L2 and here T2. Okay. This one we have done. But now what will remember that here? One thing you have to remember that here in this situation, as this is the which one? Joule means which system? MKS system. That means, students, see, this M1 is how much? 1 kg. Similarly, this L1 how much? MKS 1 meter. Similarly, T1 how much? 1 second. Okay. Similarly, if I write here this side, okay. So M2 how much? See, now we have to see from here. M2 mass how much given here? 250 gram. Okay, 250 gram. And after that, length in new system of unit, length how much given here? 20 centimeter. Okay. And if we talk about here the time how much is given here? Time is given half minute. You know, students, 1 minute is the 60 seconds. So half minute how much? 30 seconds. Okay, 30 seconds. Now what we'll do here? Both the sides the unit should match. Both the sides what should be there? The unit should match. Like here 250 gram, here 1 kilogram. So what I will make here? This 1 kilogram, I will write here the 1000 gram. Similarly, meter, but this side centimeter. So here also will match it. Here how much? 100 centimeter. Or even you can write 10 power 3, 10 to the power 2 and all that. This anyhow second and second is matching. So no problem. After that, students, what we'll do here from this, if I make it here equation 1. Okay. So students, I will write here, see, very easy, see, from equation 1. Okay. So what we have to calculate? We have to calculate X. And what is X? N2. So we will make N2 as subject. So it will become here N2, N1 and it will become here U1 by U2. Is it? Great. Now after that, see here, this is N1 and see here, this U1, this dimensional formula, U2, this dimensional formula. We'll write now, see, M1 by M2 power 1. Similarly, next one, L1 by L2. What will come? L1 by L2. Power, how much? 2, because energy is involved. Similarly, T1 by T2, how much is, students, here? Minus 2. Is it? Up to this is the clear. Now power is very, very important. Now after that, what we'll do here? Let's put the values now here. N1 value how much? Guess here. N1 value how much is there? 100. Okay. 100. And after that, see here. M1 by M2. That means, see, 1000 gram by 250 gram. So we can write here, see, 1000 gram by 250 gram here. Power 1. Okay. After that, if we go for the length how much given here? Here 100 centimeter. Here how much? 20 centimeter. So see here. It will become here 100 centimeter by 20 centimeter. Okay. And here how much? Power 2. Okay. Great. After that, if we go for the time, here 1 second. Here how much? 30 seconds. So here we'll write here, see, it will become here 1 second by 30 second, power minus 2. After that, now you can identify very well why we have converted into same units, because here now this gram, centimeter, second is cancelled over. So now after that, what this will happen here, see, this will become here 100 means 10 to the power 2 into 1000 by 250. What will come here? It will become here 4 power 1, correct na? 1000 by 250, correct na? 4 power 1. After that, if you will do here, 100 by 20 will become what? 100 by 20 means it will become 5. So 5 square, 5 square, and into this will become 30 power how much? It will become here 30 power plus 2, because 1 by 30 power minus 2, na? Take in a numerator, so it will become 30 power plus 2. So after that, students, again we'll simplify this. So see here, 10 to the power 2, it is 4 into 25, and here it will become what? 9 into 10 to the power how much coming? 9 into 10 to the power square, na? So 10 square means 100, na? 100. So anyhow, we can tell power 2. So after that, students, what this will become here? This 25 into 4. 25 into 4 how much? 100. That means 10 to the power 2 extra will come here. Okay. So what will become that here? See, this I will write here 9 into, here it is coming 10 power 2. 10 power 2 here is there. 10 power 2 here is there. That means it will come 9 into 10 to the power 6. Okay. What is coming, students? 9 into 10 to the power 6. So students, anyhow we are getting what is the value of x? 9 into 10 to the power 6 units. Okay. So 100 joule is what? 100 joule, students, 9 into 10 to the power 6 units. You can see very well in how much easy way, how much basic way we have converted from one system of unit, that is MKS, to the new system of unit, that is neither CGS nor FPS. Some new is there. So there only this M1U1 and N1U1, N2U2 and all we will use here. Okay, great. Now students, after that, see the next one, application 2, because I have told you in this video we are going to learn the two applications. Okay, so see, to express the unit of a physical quantity in terms of other physical quantities. Okay, so see here, the students, see, as unit of mass is kg, we all know it, is it? So now, but we can write unit of mass also from the formula. Now you will think, okay, unit of mass is kg, what another unit he is going to write for the mass? Okay, but here if we do little bit magic, what magic is there? See, I will just write here F equal to ma, now Newton's second law of motion. So from here, the students, what we can write here, this m will become here F by a, correct? F by a. Now students, after that, if we are going to write here the unit means what will happen here? Unit means anyhow the big bracket, now unit or dimensional formula. So force means what is there? Newton. Okay, force means what is there? Newton. And acceleration means meter per second square. What is coming? Meter per second square. So even you can write here, see, Newton second square by meter. So what I am telling you, see, the unit of mass, even we can write Newton second square per meter. Here what we can write here, see, Newton second square per meter. Is it? Now after that, if we write here in one standard form, just take like this, see, the unit of mass. Now Newton means, if I write here the force, that means F power 1. Second square means we can write here what? T power minus 2 or plus 2? Plus 2. And length means L power minus 1. So you can write F power 1, T power 2 and L power minus 1. Now can you see very well? Is it? So Newton second square per meter here, is it? Or we can write F power 1, T power 2 and L power minus 1. Na? So that is the unit of mass in terms of force, length and time. Now after that, see, na, there we have done it, but number of times we are not that much fortunate, so we can guess one formula. So there what we have to do, we have to go with the basics. Okay, so see here, the question is this: if pressure, velocity and time are taken as fundamental quantities, then dimensional formula of force how much? Dimensional formula of the force they are asking. Okay, so students, here I will write here this dimensional formula of the force depends upon pressure, velocity and time. Okay, so I will write here pressure power A, na, unknown, velocity power B, and here how much is there? Time power C. Okay, time power C. After that, next one what we are going to do, both the sides we are going to write here the standard dimensional formula. So m power 1, L power 1, T power minus 2. Okay, pressure, as we have done before also, na, pressure means force by area and area means L square. So when you will do na force by area, ml minus 1, T power minus 2 power A. At least this we should remember. Okay, otherwise it will become tough. So velocity means LT minus 1 power B and time means anyhow C. Okay, Now after that, if we go for this one, we can write here C, m power 1, L power 1, and here how much is t power minus 2 is equal to, now here you see, m power how much? Here 1, so 1 into a, m power a. L power how much? Here L power, how much is there? Minus a, because minus 1 into a, minus a. After that here, what will become that here? See, here L power 1, so 1 into b plus b. See here, na? Minus a plus b. Going correct? Great. Now after that, t power how much is there? Here t power minus 2a. Here t power how much? Minus b. Here how much t power? C. So minus 2a minus b plus c. Now, kindly see very well. Na? M power a, L power minus a plus b, and t power minus 2a minus b plus c. Now what we'll do, both the sides we will compare here. No? So both the sides will compare. So when we'll compare here, what we can write here, see, here a power how much? 1. A power how much we got here? A power we have got here 1. Next one, means a equal to 1. A equal to 1. Now both the sides we are comparing mass. Now if you compare the length, so here length how much here? Minus a plus b is equal to here how much? 1. That means we can write here b equal to, what we can write here? 1 plus a. What is the value of a? 1. So what will happen that here? This will become here, when I will put the value of a1, the value of b will become here 2. Okay, this one we have got here. After that, if we go for the time, compare the time. So here what will happen that, see, the minus 2a minus b plus c is equal to how much, students? Here the minus 2. So when you will write here the c will become what? C will become here minus 2 plus 2a and plus b. Correct? C equal to minus 2 plus 2a plus b. Now after that, just put the values here. See, this will become here minus 2 plus a value 1. So 2 into 1, 2, plus b value how much came? 2. Okay, so this minus 2 plus 2 cancel. So what we are getting here? The value of c, we are getting here the 2. So see, you can see very well, the a value is 1, b value is 2, and c value is also 2. So you can see here, a value 1, b value 2, and c value how much? 2. So you can see very well what is coming here. The correct option is here. The correct option is here option B, p power 1, v square and t square. Na? Kindly see here very well. This kind of approach we have to do it when this question they have asked where? In NET and all that. If in case directly MCQ is there here. Okay. So students, here I will talk about here one shortcut. Here we have to do try and error method. Okay, so here we have to check one by one options and all that. Now see, I have got this option now. So see, if I will do here, see, P1 and here V square and here T square. Okay, so you know very well, P means what? ML minus 1 and T power minus 2. Velocity is square. So what will become? LT minus 1 is square. So L square T power minus 2. Similarly, time, that means time will become what? T square. Okay, students. So when you will simplify this, what will come here? M power 1. L power, what will come here? See here, minus 1 and here 2. So L power 1. And T power, how much will come here? See, this minus 2 and plus 2 cancelled. So here minus 2 is coming here. So see here also you can get here the dimensions from the force. So students, this cost shortcut you have to use whenever some options are there, na, so that you can check one by one. Option A, option B, option C, option D, na, you can check it. If NET is there, na, then you can go like this. But in a board exam and all, if they ask, not board exam, in 11th, when you are doing, na, you want to learn the basics and all, na, so that time you can go like this. That's not a problem here. Okay, good. Now students, see here. JEE 2023 question. Now you see, same story. Force, velocity and time are taken as fundamental quantities. Then dimensional formula of density will be how much? Dimensional formula of the density they are asking here. Okay. Now I hope so most of you can get it very well. But okay, anyhow, like here, see, the density means D is a force. That means we can write here F power A. Next one, velocity, V power B, and time means T power C. Correct? Yes. Now after that, see the same story. Even you can do by the option checking also. But first I am teaching you basics. M power 1, L power minus 3, T power 0. Because density equal to mass by volume. Okay. Similarly, students, here force means here MLT minus 2 power A. Velocity means LT minus 1 power B. And time means anyhow C here. Okay, here let me write here. Now after that, what we can write here, see, as we have done before, M power 1, L power minus 3 and T power 0. Correct na? Yes. Now after that, see here m power, what we can write here? See 1 into a, only this is there. L power, what we can write? L power, see 1 into a, so here a, 1 into b, so b, and anything else, see 1 into a, so L power a, and here 1 into b, so a plus b here. After that, see if we talk about the time here, time, what this will become here? See the time is given here, students, see here t power minus 2a, here t power minus 1 into b minus b plus c. Okay, now after that, both the sides again we are going to compare. Okay, so see, if we will compare the exponents of mass, m power 1 and here m power a. So what is the value of a? A is going to come 1. There is no doubt in it. Okay. After that, if we compare the exponents of the length, then what will come? Here length minus 3. Here length how much? A plus b. So we can write here a plus b equal to minus 3. So b will come what? Minus 3 minus a. A value how much? 1. So minus 3 minus 1, how much coming here? Minus 4. So students, the b value is coming here what? The b value is coming minus 4. After that, if we go for the time, compare both the sides. Here minus 2a minus b plus c, and here how much is 0. So see, minus 2a minus b plus c equal to how much? 0. So what c will come? C will come here 2a plus b. Okay. So 2a, that means 2 into 1, what is coming? 2. And after that, b value how much? Minus 4. So what this will become here? It will become here minus 2. This is the value of the c. Now you can guess here the options very well. See a power 1, b power minus 4, c power minus 2. So f power 1 here, v power minus 4, t power minus 2. That means correct option is what? The correct option is here option C very easily. Okay. And if we talk about here the shortcut, shortcut. As I have told you before also shortcut. So here the students, when we will just do the shortcut. So what we know very well, see f power 1, v power minus 4 and t power minus 2. This is the story now, right here in a bracket. So f means what? Anyhow, see mlt minus 2 power 1. Velocity means lt minus 1 power minus 4. Okay. And time means power minus 2. Definitely, when you will simplify this, it will come m power 1, L power minus 3, and that is the dimensional formula of the density shortcut. So students, kindly see very well. So students, I hope so this video and the 2 applications you have understood very well. In next video, we are going to learn further 2 or 3 more applications. Keep studying, keep going.